Hello, this is Hui. Welcome to watch my video, C++ programming on Linux. In this short video, we will continue talk about the SSH Server API. On our channel, we have already made few videos showing how to write a C++ network programming of TCP, TLS, SSL, HTTP, and HTTPS servers using different libraries like OpenSSL, WolfSSL, Boost C++ API, libevent, and others. In this short video, our example will write a C++ program to create a classical SSH Server API using libssh. Here is the basic TCP client server process diagram. In general, a SSH server is actually a type of TCP server using SSH protocol. The standard process of network programming: first, both client and the server have to open a socket. On server side, after create a socket binding and start listening for client connections. On client side, after open the socket, send a request to connect to the server. Server received client connection request, validate like a handshake, and accept client connection. Then it will establish the communication between the server and the client. So server can read client message and write message to the client, and the client can read server message. Finish all the communication process, both client and the server have to close the socket. Here on our Ubuntu Linux, first we are going to create a C++ program, SSH Server.cpp. To build a libssh SSH Server API, the header file will be the libssh.h, server.h, and callback.h. For handling multi-client connections, the standard way or most popular way on server side are either using multi-thread or fork system call to create a child process. libssh support both multi-threading and fork system call. In this example, we're going to use multi-threading model, and as per document, pthread is recommended by libssh. For handling SSH session and channel data processing, libssh has provided many functions. For processing on server side, instead of directly using this SSH session or SSH channel API functions, new version of libssh has moved to callback and event loop architecture. In this way, it will be simplified to customize server-side programming. Here is the SSH Server callback struct reference web page. It's derived from the SSH session struct, SSH channel struct, and the SSH string struct. Here is the struct field. The user date is the parameter that will pass to these callback functions. Although password callback function is for processing, login, password, callback. So when client requests password authentication, this callback will be triggered, so you can customize and process login and password authentication. Service request function will be triggered when client make a service request. Here is the channel callback struct reference. user date field is the parameter that will pass this callbacks, and the channel date function will be triggered if a channel has data available for reading. Channel EOF callback will be triggered if a client sends the EOF request to the server, and the channel close callback will be triggered if a client sends the channel close request. You can customize and set this callback structure. Then this callback function will be automatically triggered when client make a corresponding request to the server. Back to our Linux editor, we're going to define and declare some glob variable and parameters. The struct glob date will be the user date struct for the whole API. This struct contains the server, port number, login ID, password, and the IS key. These all are mandatory date and parameter for start a server. Struct session date is the date that I need to keep when the client request has been accepted, like a channel, data received byte, client authenticate attempts for authentication processing, and the erase flag. We define a glob date gparm and create a vector to store session date for each client connection has been accepted. And the two help function, check and purge vector, and search and locate date vector. Next, in the main functions, the usage, it will take a 5 argument, server URI, port number, login ID, path of RSA key file, and the log level, value from 0 to 3. 0 is no log, 3 is the maximum log. After validate command line argument, we copy argument 1 to glob parameter server, argument 2 copy to the glob parameter port number, argument 3 copy to the glob parameter login ID, and argument 4 will copy to glob parameter RSA key. Usually, this RS key is under home.ssh directory. Here is the RSA private key, and here is the RSA public key. SSH Server supports both RSA or DSA keys. This file can be generated using SSH kgen command. Here is the menu of command SSH kgen. Using this command, it will be able to generate either RSA key or DSA keys. In our example, we skip this. Back to our editor again. We use SSH get pass function to get the password from console, and if return is okay, we can start process our server. Here is the main process for build a SSH server. Step 1 is initialize glob SSH data structure. Function is SSH init, and the last step is finalize and clean up SSH date structure. Function will be SSH finalize. All the other process will be between SSH init and SSH finalize. 2dd, let me paste here. Step 2 will be create SSH binding object. Function will be SSH binding new. Return is the SSH binding pointer. If return is none, it means SSH binding new failed. So we print out error message. Return the -1. Step 3 will be the set server options. Function will be SSH binding option set. First parameter is SSH binding pointer. First option is server address. Second port number. from argument 2. Third option, RSA key from argument 4. Next option is a log level from argument file. In general, you can set up more options. These 4 are basic options for set up a SSH server. After that, we'll start listening. Function SSH bind listen. If return code less than 0, it means error. Function to get error. First RC, return code. Second is error message. Free binding, finalize, and return -1. Success, print out message, server started listening. Argument 1 is the server. Argument 2 is the port numbers. Now we start loop listening client connection. First we check and purge session date vector. We start a new session. Function is SSH new. If session is none, it means error. Then we print the error message, sleep 1 second, then continue, loop again. Next, waiting and accept client connection request. Function SSH binding accept. If return code is SSH error, print error message, disconnect and free the session. And continue for next loop. Using function SSH get error code and SSH get error to get the error description. Step 5.3, create a thread handling session and channel functions. As we mentioned, libssh recommended to use pthread. Declare a variable pthread TID, client ID +1. Function for create a pthread is a pthread create. First parameter is pthread ID pointer. Second parameter will be the restriction. We are not using here none. And the pthread function, we name it my session thread function. Parameter passed to this function is a session. If return code equals 0, using function pthread detach, detach the pthread, and continue. Finish from the loop, we are going to closing process where we disconnect, free the session, and free the network bindings. Function SSH disconnect, SSH free, and free the socket binding, allocate the memory before exit, finalize, and clean up all the data structures. Next, we are going to create an editor thread function, my session thread function. Parameter passed to this function will be the session. Argument will be the session. Declare a local parameter. Copy glob date parameter to the local. To save typing, we just copy and paste here my local parameter ID port number, server, login ID, local RSA key, and the local password from the global parameter. Next will be save session date to session date vector. Vector session date. Then call the function my handle session to process. This function take two parameter, local parameter and session. Finish this function, we are going to mark vector erase flag. If the state ID equal my parameter ID, then we mark erase flag once. We can print out message. Before exit, disconnect session and free the session. Return none. Next, we are going to create the function my handle session. This function will take two parameters, my parameter and the session. The task of this function will be step 1, search and locate session record in session vector and print the info message. This function has been invoked during the SSH session key exchange. Create an event object, declare and initialize channel callback struct, declare and initialize server callback struct. Set authenticate method, callback initialize for server, callback initialize for channel callback, set server callback to the session and add our session to the event loop and check authentication 3 times. If success, then continue, set channel callback. Copy this 7 line, 7YY. Declare return code RC. And IVect, index of vector, location of session date in session vector. Make a loop. If vector ID equal my parameter ID, it means we located. IVector equal I. And next, we're going to print information. This function has been invoked. My parameter ID, my vector index. Next step, handling session key exchange. Function is SSH handle key exchange. Is not SSH OK, it means error. If error, we print out message. Function SSH handle key exchange the error code and the error descriptions. Otherwise, print the SSH handle key exchange success. Next, create new event object, my event. Function SSH event new. Next step, declare and initialize SSH channel callback struct. Structure SSH channel callback. First field is the size. Based on the document, do not set this. Use SSH callback init function instead. Second is the user date, which is the parameter passed to all below 15 callback functions. Next is the channel date function. This function will be called when there's a date available. This is the main function in this demo example. Next is the EOF function. This function will be called when the channel has received a EOF. Channel close function will be called when the channel has been closed by remote. In our demo, we are going to use all these three functions. Back to our editor. First, we copy the base of channel callback structure. For the user date, we are going to pass my parameter. For the channel date function, we name this my channel data function CB. For the EOF, my channel EOF CB. For the channel close, my channel close CB. Next will be declare and initialize SSH Server callback. Struct SSH Server callback. First field is the size and the user date is the parameter or passed to each callback function. There's 4 authentication function: password authentication, node authentication, GSS API MIC authentication, and public key authentications. GSS API stands for Generic Security Service Application Program Interface. MIC stands for Message Integrity Check. We copy the basic of this structure. Back to our editor. We declare the base of this callback structure. User date, my parameter. For our demo, we only use password authentication function name. Service request function. And open channel request. Later on, we're going to create this function. Next, set authentication method. In this demo, we're going to use password authentication. Function is SSH set auto method, password authentication. Next, initialize service callback and channel callback. Next step, set server callback with the session. Function is SSH set server callback. First parameter is the session. Second parameter is server callback. And next step, add session to my event object. Function is SSH event add sessions. After that, loop authenticate 3 times in 10 seconds. Authenticate flag equals 0. Session has not been authenticated yet. Oh. Channel is still not open yet. If attempts greater than 3 or n greater than 100, it means over the 3 times for 10 seconds. So we freeze my event. Return from this function. In each loop, pull event to check authentication 3 times in 10 seconds. First parameter is my event. Second parameter 100 milliseconds. If get error, free event, return and print error message. Copy this 2 line to YY. Event do poll function, get error, error code, error message. Finish authentication loop. It means authentication success. And we are going to set channel callback. Function is SSH set channel callback. First parameter is the channel. Second is structure channel callback. If return code is error, copy this 4 line for YY. We print the error message. SSH set channel callback error. No error, print the message. Set channel callback success. Next. Pull the event while channel is open. Do in each loop, we copy this two line to YY, print error message, sleep 1 second, and then try again. Finish the loop, channel is closed. Free my event. Now we finish function, my handling session. Finish this function, we're going to start create our callback functions. Based on our setup, we have to write 3 server callback functions and 3 channel callback functions. Here is the list of callback functions we're going to create. On server callback, we're going to create authentication password callback function. SSH auto password callback function have to be in server. It will take 4 parameters: session, user login, password, and the user date, which is a parameter passed to this function. And this function will return SSH auto success, partial or denied. Copy this line. Back to our editor. Name my auto password callback. Decoding the parameter. Search session date in vector. Print out info message. Attempts +1. If login ID and password match, print out message. Authenticator flag set to 1. Return authenticator success. Else. Next callback function is my service request callback function. My service request callback handling SSH service request. It will take 3 parameters: session, service, and the user date, which is the parameter passed to this function. This function returns 0 if request is to be allowed. -1 should be not allowed. Back to our editor. Function name, my service request callback, decoding user date. If session is none, print an error message. Otherwise, return SSH is OK. Print the message, service allowed. Next callback is channel open request session function callback. Function SSH channel open request session callback handling SSH new channel open session request. This function takes 2 parameters, session and the user date. This function returns a valid SSH channel handle. If success, none is errors. So we copy this line, Back to our editor. Function name, my channel open session CB. First decoding the parameter. Search and locate session date vector. Copy this for line for YY. For error, print a message. Success, print the info. Return. Now finish 3 server callback. We're going to write 3 channel callback functions. First is my channel close callback. Function channel close callback code when a channel is closed by remote peer. This function takes 3 parameters: session, channel, and the user date, which is a parameter. So we copy this line. Back to our editor. Function name is my channel close callback. We print out info message. This function has been invoked. And then doing the channel close. Next function will be the channel EOF functions. Function SSH channel EOF callback code when the channel receives EOF. This function takes 3 parameters: session, channel, and the user date, which is the parameter passed to this function. So we copy this line. Back to our editor. Function name, my channel EOF CB, 3YY, copy this 3 line. Print the information. This function has been invoked. SSH channel send EOF. Next callback function is my channel date function, which is our echo server receive date and echo back the date. Function SSH channel date callback code when date is available on a channels. This function takes 6 parameters: session, channel, the date read on the channel, the length of the date is std error, and the user date, which is the parameter passed to these functions. Return is the number of bytes processed by the call. All remaining bytes will be sent in the next callback messages. So we copy this line. Back to our editor. Function name is my channel date function CB. Print the information. My channel data function CB has been invoked. Let's copy this for line for YY. Search and locate date in vector. If you cannot find the record in session data vector, then we return error. Print out. Byte we received, the date we received. After print, echo back. Then we return SSH OK. Finish all our callback functions, save our program, compile our program, and test it. WQ. Now our server has been saved. To test our SSH Echo server, it requires a SSH client. Here we have a create SSH date client.cpp. It's similar to previous video's example, and we made a modification on that. Instead of send a command to remote SSH server for executing, it will input the data from terminal and send to remote SSH server as date, then read server reply back. The usage take a 3 argument: server, port number, and the login ID. We compile our program. We compile both client and the server. Now our program has been compiled. Here is our server executable. Here is our client executable. To test our example, we are going to use 3 terminals. On the top terminal, we are going to run our server. Server 10.0.0.191, port number 1234, login ID is HYUAN, RSA key is under .SSH, ID RSA, and 0 is no log, password. Now our server has started listening on the port number 1234. 2 bottom terminal will simultaneously run 2 clients. On this client, after password authenticated success, our server accept connection request, start a handler session, and now client is ready for type message sent to server. Test message 1 from client 1. So you can see our server received message, reply back, and our client received same message. Here on the other terminal, we start another client, password. After type the password, we send the authenticated request to the server. Server received, accept the connection. So now we type test message 1 from client 2. So you can see client 2 send the message to server, and the server reply back, and the client 2 received same message. We try to go back to send message from client 1 again. Client 1 send the message 2 to server, which server received, reply back, and the client 1 received same message. SSH and SSL TLS are both cryptographic protocol used to secure communication, but they serve different primary purpose and operate at different levels. SSH Secure Shell primarily designed for secure remote access and system administration. Instead, SSL TLS Secure Socket Layer Transport Layer Security primarily designed to secure data exchange between client and the server. This is Hui. Thanks for watching my video. Wish it's useful, and it's going to be great to have your feedback.